You can write it in the chat bar, or you can use your microphone to suggest. Does anybody remember what happens when we get a negative outside of a bracket like this? This has to do with the distributive property. So when you get a negative in front of a bracket like this is going to multiply everything that's inside your brackets by a negative. So what we're going to get is x plus y, because we remember that -1 times a -1 is going to give us a positive value. So this is what happens when we open up the brackets that way. We can also subtract. We can start off with a negative value and subtract another negative. So we're subtracting from a negation. And there's a couple different ways we can look at this. The opposite of the distributive property that we were talking about last week allows us to write this as negative x plus y, because they're both negative. So if you remember from last week, when we had the distributive property, we started out with this left side, and we were distributing the negative inside to each one of these terms. And that's how we would get what's over here. So it's kind of working backwards. But I just wanted you to see that these statements are equivalent. When we have negatives in play. A third case is if we have a negative x minus y. What's going to happen in this case? How do we simplify this if we can write it without the brackets? What do these terms become?
A positive, maybe.
Well, let's look to see what's happening. We have a negative, and it's applying to a positive number, a positive x. So that's like saying -1 times x. Is that going to give us positive x or negative x?
Negative x.
It's going to give us a negative x there. So the first term here is going to be negative x. And then we're going to apply that negative again to a negative y. So it's like we have -1 times negative y. Are we going to get a positive y or a negative y here?
Positive.
Sorry, I couldn't hear. Someone suggested it. Is it Samson? Can you say it again?
I didn't say anything.
Okay. Somebody else said something. I couldn't hear.
A positive.
Positive. Yeah. Yeah, we're going to get positive y. We don't need to write the sign out, but we can write it out just to remember. So this is going to be negative x plus y. So negatives, when we have negatives outside of a bracket, we can just think about them as if we had a number out front of the bracket, and which is -1. And we're distributing that -1 to every term inside the bracket when we want to expand the brackets. Does anybody have any questions about this? Okay, so we'll see lots of examples of this today. Just going to save my slides here. So one question is, is A minus B minus C equal to A minus B minus C. So this is about associativity. This is, in other words, is subtraction associative. And remember, for addition, remember the associative property said that A plus B plus C is equal to A plus B plus C. That's for addition. And for multiplication, A, B times C is equal to A times B times C for multiplication. So that's what we saw last week for the associative property. So does this make sense, this statement here? Based on what we, how we simplified stuff in the last slide? Maybe we could just write them without the negatives. Sorry, without the parentheses. Is there a way that we can write these without the parentheses? Can I write the left side without the parentheses? What do people think?
Yes, but for the left side you could write it without parentheses. But then for the right side it equals to A minus B plus C, not minus C.
Right. So that negative out front distributed to each one of those and switched their signs. So we get A minus B plus C, exactly. So we can see right, excuse me, we can see right away that this is not equal. This is definitely not equal. Just by removing the parentheses, we can see that, you know, this is never going to work. We can try it like we did last week. Remember, we substituted in, somebody substituted in some values, say like if A equals 1, B equals 1, and C equals 1, and just see that way. But we've already shown in general, without having to sub in numbers, that it's not true. So therefore, we can say that subtraction is not associative. And it turns out it's not associative or commutative. So it doesn't follow the same rules that we were talking about last week. But one way that we can work with subtraction to make it associative and commutative is to turn all the negatives into positives. I'm just going to write that down. We can use commutative, associative properties if we turn negatives into, until we turn negative subtraction into addition of negatives, negative numbers. So I'll tell you what that means. So we want to be able to use the commutative and associative properties with negative numbers. So the way that we do that is, here's an example. If we were being asked to find the value of 1643 minus 1994 minus 1643. Now this might be a really easy example. You might say right away you know the answer to it, but what you're doing in your head probably is you're using the commutative property already in the associative property. So if we just take this and rewrite this, we can see right away that the two numbers that would be easiest to add together are these 1643 and minus 1643. So what we want to do is convert this to additions. We want to say 1643 plus negative 1994 plus negative 1643. So we've converted our subtractions to additions. So now we're just adding, we're adding negative numbers. Instead of subtracting positive numbers, we're adding negative numbers. So it's kind of it's a subtle difference, but it's going to allow us to move these numbers anywhere we want now. We can say, okay, this is 1643 plus minus 1643, and then plus minus 1994. So now we just rearranged. That was using the commutative property. We rearranged using the commutative property. And of course, we can take away the brackets now if we want to. 1643 plus minus 1643. We could rewrite that without the brackets. But now you're saying, well, why would I bother doing this? Why would I bother putting brackets around it to move it around and then just take the brackets away? It seems like extra steps. And it is. But it's going to be important to be able to do this when you have more complicated terms. So like with variables and things like that involved. So we know that's going to be 0 minus 1994, which again, we're going to say is minus 1994. So this is just like the simplest way I can show you what I mean when we want to use the commutative property with subtraction. Because we can't start, we have to remember that when we move negative numbers around or subtractions around, we have to carry the negative with it. So that's something that people tend to make a mistake on when they want to move negative numbers. Lots of times they forget to move the negative. So this is just a reminder that in order to move terms around, the negative is always stuck with the number. So we can move it by converting them to additions here. One thing we saw last week was the distributive property. I'm just going to write that out again. We talked quite a bit about the distributive property, and hopefully you got some practice with that. So A times B plus C is equal to AB plus AC if we distributed the A to both of those terms. So multiplication also works for, it also distributes over subtraction. So we could say that A times B minus C, this is fine. It's going to be AB minus AC. So the negative sign in the bracket there didn't affect the distributive property. So we've done some examples of that. Just going to look ahead to this next example. So if we had an example like negative 2 times 3x minus 2y, and we were asked to expand this, what are we going to get? There's a couple different things we could do. A couple different ways we could write this that would be equivalent. So if I want to expand these brackets, I should actually say, instead of example, I should say, we've been asked to expand. And that means expand the parentheses. How would I write this out without the brackets? What would be an equivalent expression? If I'm making use of the distributive property. Anybody have an idea what the equivalent expression would be here without the brackets?
Negative 6y plus 4y.
Yeah, you mean negative 6x, yeah, plus 4y, yeah. Right. So what we did here, I'm gonna write that down here, negative 6x plus 4y, and we're just gonna back up a second just to show the steps here. So we want to distribute that negative 2 into each term. So what we're going to say is negative 2 times 3x. And then we can say plus negative 2 times negative 2y. Because we just want to add the terms. We know all the terms in a bracket are essentially being added together, but some of them are negative. So we can write it like that. And of course, if we distribute this, we just added more brackets basically. But you're right that negative 2 times 3x is going to give us negative 6x. And this is going to give us positive 4y. So that's a way we can think about distributing and writing using the distributive property with negatives involved. So we'll see lots of examples of this. You'll get lots of practice. So it's not going to be hard to get the hang of that. Just going to save my slides here. Another thing I want to talk about today is reciprocals. A reciprocal. Has anybody seen a reciprocal before? The reciprocal of x is 1 over x. So if I say, what's the reciprocal of x? We're going to write 1 over x. We have flipped the variable or flipped the number. So the reciprocal of 2 would be 1 over 2. And I'm going to write the reciprocal of a number is what you need to multiply by to get 1. So if we have a number and we multiply it by its reciprocal, if we remember our fraction rules, this is like saying I have x over 1 times 1 over x. And when I'm multiplying fractions, I'm going to multiply the numerators and the denominators to give us x times 1 on top. I'm just going to write it like that. And 1 times x on the bottom. This is going to give me x over x. And anything over itself is just equal to 1. So this is using a few different ideas that we haven't talked about yet. We haven't talked about fractions. How many people are familiar with fractions? with adding, subtracting, multiplying, and dividing fractions?
I have worked with fractions before.
Cool.
I
So
have.
most people, awesome. So most people are familiar with these operations. Okay, cool. So this is the idea of the reciprocal. It's 1 over the original number or variable. So if I have, you know, something like 2, and I'm going to multiply it by 1/2, 1/2 is the reciprocal of 2. That's just going to give me 1. So we can say, therefore, 1/2 is the reciprocal of 2. There's a few things that we have to pay attention to when we're talking about a reciprocal. One of them is, what do we get if we have 1 over 0? Does anybody remember what happens when we try to divide something by 0? What does your calculator tell you when you try to do that?
It doesn't make sense.
Yeah, your calculator gets mad. It says error or undefined. We can never divide by 0. That doesn't make sense in mathematics. We can never divide by 0. So we say that 0 has no reciprocal. So 1 over 0 does not exist. So that's important, because we have to make sure we're never going to end up with 0 on the bottom of a fraction. That'll become important later when we're solving some equations. Another way we could look at it is there's nothing we could multiply by 0 to get 1. If we're going with our definition of what the reciprocal is. So this might be some review, but I wanted us to work with some fractions a little bit today. Compute the product of 5 times 7 and 1/5 times 1 over 7. 1/5 times 1/7. So we have a product of these two numbers here, these two terms, and each of these terms is a product in itself. So we could say that this is equal to 5 times 7 times 1/5 times 1/7. So we want to compute this product. Again, I'm not using multiplication signs. I'm just using the dot, which means multiply. So how can I think about this? We can use, how can I simplify this product? Carry out this multiplication in a way that would be easy. We can think about the commutative property and the associative property as they apply to multiplication. Is there, what would be the easy ones to multiply together? Well, we could say, do I need to write this with brackets at all? Can I write it without the brackets? Is there an equivalent expression? Could I just write 5 times 7 times 1/5 times 1/7? Is that equivalent? Well, it turns out it is equivalent because all these brackets were doing is just telling me that I'm multiplying these terms together. And all that's happening inside these brackets is just multiplication. So this is just basically 3 multiplications in a row. So I am allowed to do that, to take these brackets away. And just write it like this. Now that we have it written without the brackets, maybe we could choose some pairs to get multiplied together. I could multiply 5 times 7 and get 35, but maybe it would be more helpful to multiply 5 times 1/5. What happens when I get 5 times 1/5? What does this product end up being? 5
1.
times 1. 1, exactly. This is going to be equal to 1 over 1 times 1 over 1. I mean, what I should do is I should write out what it actually is, which is 5 over 5 first, and 7 over 7, which is 1 times 1. So everything is equal to 1. What started out looking like something kind of, complicated, these fractions and numbers multiplied together, just by grouping them using the associative and commutative properties, we can say, I can simplify this all to 1. So that's what we were talking about mostly last week, but this also tells us something else. Because this was sort of like writing, this was like writing 35 times 1 over 35, which is also just equal to 1. So what we've learned from this is that when we have a reciprocal that has multiple factors in it, we can split them up. And I'll show you what I mean by that. In general, just going to save my slide here. In general, we say that the reciprocal of xy is equal to xy is 1 over xy. So the reciprocal, you can take the reciprocal of anything. We could say the reciprocal of, x, like 4xyz squared, if we have some exponents, is going to be 1 over 4xyz squared. So really reciprocal, you can take the reciprocal of anything. It's just 1 over that thing. What is the reciprocal of -8? What's the reciprocal of -8?
Zero.
Sorry, what was that? Samson, did you say something?
No.
If we remember what our definition of the reciprocal was, we could say -8 times something has to equal 1. We want it to equal 1. What if we multiplied -8 by? to get 1.
One over -8.
1 over -8. That's a pretty good suggestion. Let's see what we get here. 1 over -8. If we multiply this, remember it's like we have -8 over 1 there when we have a whole number multiplying a fraction. And we can say we're going to multiply our numerator and our denominators. And we are going to get -8 times 1 on the top and 1 times -8 on the bottom. I shouldn't be putting brackets around these because they have a negative. And so that gives us -8 over -8, which is 1. So when we have a negative involved, it's still just 1 over that value. The reciprocal is always just 1 over the value. So I should write 1 over -8 is the reciprocal of -8. Another thing I wanted to go over, and a lot of this stuff is our mathematical rules that you're probably familiar with already, but I want to make sure everyone's on the same page here. We'll get to more complicated word problems soon, but I wanted to talk about the equivalence of writing a negative in a fraction. Does it matter where we put the negative? Is this equivalent to writing this? And is that equivalent to writing this? Does it matter where we write the negative in this fraction? And we could think about it like this. I could think about it in terms of another fraction. I could say, is -4 divided by 2 equal to 4 divided by -2 equal to -4 divided by 2? Are these all equal?
Yes.
Yeah, if I have -4 divided by 2, I'm going to get -2. And the same thing, 4 divided by -2 is going to give us -2. And this is just -2. This 4 over 2 is 2. So this is definitely equivalent. It doesn't matter where you write the negative in a fraction, as long as there's just one negative. Where some people get mixed up sometimes, we never want to write negative 1 over, whoops. We never want to write like -1 over -2 and just leave it like that. We never want 2 negatives in a fraction. So if we have 2 negatives in a fraction, this is like saying we have a -1 divided by -2. And a negative divided by a negative is going to give us a positive. So this is just going to be 1/2. So two negatives in a fraction, so numerator negative and denominator negative, will cancel out. But this is important because I want to make sure that everybody knows that these are equivalent. So wherever you see the negative, you could bring it up or down. Usually we don't see this one very often. You don't want to leave the negative in the denominator of your fraction. You want to write it in the top or in front. So if you get a situation like this, you can move it. You can move the negative up. Okay. I have another example here, or a question that says, compute 2 times 3 times 4 times 1/2 plus 1/3 plus 1/4. So there's more than one way to do this computation. What's one way that people would do this computation if you're asked to do this? What's one way we could simplify this? And we could, you know, people could be thinking about PEMDAS, right? PEMDAS tells me that I need to do my parentheses first, evaluate what's in the parentheses first. But we don't have to do that. So what's one way we could do this? It's not, there's no wrong way to do it. What would be your first instinct? Well, could I simplify what's in the brackets here? If we're looking at PEMDAS, PEMDAS tells me I need to simplify what's in the brackets. So could we simplify 2 times 3 times 4? What would that simplify to?
We could use association property and group the 2 and 3 together and then times 4.
Okay, sure. We can multiply 2 times 3 times 4. Yeah. And the associative property, I mean, when we have numbers multiplied together like this, we don't necessarily have to do it in 2 steps. But like you said, we could say, okay, 2 times 3 times 4 if we wanted to. And we could say, okay, this is going to be 2 times 3 is 6 times 4 is 24. However you want to arrive at that. What are we going to have to do here with this bracket? How do we add these together? Do people remember their rules for addition of fractions? We would need a common denominator to get all of these fractions added together. Do people remember that? Common denominator? We'll go back to that because we're not really talking about fractions right now. the way that the book, I'm going to back up a second. So because we were given a product, we got a 2, we got a 3, and we got a 4 in our product, and we're given 3 fractions, 1/2, 1/3, and 1/4. We see these numbers again, 2, 3, 4, 2, 3, 4. So one way that the book is suggesting, this is sort of leading us to say, well, remember what I was talking about reciprocals? If you multiply a number by its reciprocal, we're just going to get 1. So it would be really convenient if we had, well, it would be really convenient if we had 1 over 2 times 3 times 4, but that's not what we have. We have 1 over 2 and 1 over 3 and 1 over 4 as separate fractions. So what we could do is we could distribute this 2 times 3 times 4 to each of these fractions so that we can open up the parentheses. So what we're going to get is 2 times 3 times 4 times 1/2 plus 2 times 3 times 4 times 1/3 plus 2 times 3 times 4 times 1/4. Does everybody see that that's how that bracket out front would distribute into each one of these fractions? So the reason why this is good for us, and this is going back to what Shayla said about the associative property, we could use the associative property because which ones would be useful to multiply together first? If I have 2 times 3 times 4 times 1/2, which 2 of these would I want to multiply together first, knowing what we know about reciprocals?
Two times 4.
Well, 2 times 4, you know, we could do 2 times 4 is 8. But we're still going to get left with this. We still have this 1/2 here. But if we think about reciprocal, what is 1/2 the reciprocal of? One half is the reciprocal of
2.
2. Yeah. So 1/2 and 2 are reciprocals of each other. So we could say, if we multiply those together first, I could say this is 2 times 1/2 times 3 times 4. Using my commutative property, because I can move things around. I can change the order that I multiply things in. And if I do that, 2 times 1/2 is just equal to 1. So we've gotten rid of the fraction just by choosing one of the factors in this bracket to multiply by first. We're going to still have to multiply by 3 and 4, but seeing as we multiplied 1/2 times 2 first, we've gotten rid of the fraction. And this first one is just equal to, it's equal to 12. So if I apply the same reasoning to the second bracket, I could say, well, the 2 that I want to multiply together first are 3 times the third. And then say times 2 times 4. So 3 times the third is just equal to 1 times 2 times 4. So we're going to get 1 times 2 times 4, which is 8. And applying it again to the third bracket, 2 times 3 times, well, the first ones I want to multiply together are 4 and 1/4, and then 2 times 3. So this is going to be equal to 1 times 2 times 3. So in each case, I'm choosing the reciprocal. I'm choosing the number that I want to multiply by the reciprocal by to cancel it out to be 1. So this is going to be 1 times 2 times 3, which is 6. And these are easy to add together. Just give us 26. So we didn't have to use any common denominator. We didn't have to add any fractions together, which is we can do that, but it takes more steps to do that. If we just choose which ones we want to multiply by first, we can make things easier on ourselves. So that's one of the exercises from this chapter. Are there any questions about this? About the example I just did here? Because I want to move on to division now. Division is the last operation I want to talk about in terms of commutativity and associativity. So division, A divided by B, we could write that as A times 1 over B. That's what our definition of division is. So if I want to divide by a number, I'm going to be multiplying by its reciprocal. Because A divided by B, we can write that as, I should write that as A over B, right? We're used to saying that. A over B is A divided by B. But I can also write this as, this is the same thing as like A over 1 times 1 over B. This is like if we had two fractions multiplied together, and one of them was A over 1 and the other one was 1 over B. So I could say, well, this is A over 1 is just A. So A, this is just equivalent to A times 1 over B. So this is important to be able to say A divided by B is going to be equal to A times 1 over B. This is the way we want to think about division all the time from now on. Instead of thinking about division as something divided by something, we're going to think about it as something times its reciprocal, something times a reciprocal. So in other words, dividing by a number really means multiplying by its reciprocal. Okay, so that's an important idea there. Dividing by a number means multiplying by its reciprocal. Save my slide here. So what if we had 10 divided by 2? Well, 10 divided by 2, we could say, now we know that this is really equal to 10 times 1 over 2 by the rule that we just discovered. And we could say, well, 10, if we wanted to, we could write this as 10 is equal to 5 times 2 times 1/2, because 10 is just 5 times 2. And now that we've written it as 5 times 2, instead of writing 10, I'm writing 5 times 2. Now I can see, oh, hey, I've got a number multiplying by its reciprocal. I'm taking a factor of 10 and pairing it up with the 1/2. I can say this is equal now to 5 times 1. So although everybody probably knows what 10 divided by 2 is, you maybe haven't thought about it in terms of this way, in terms of multiplying by the reciprocal here of 2, and then splitting 10 up into its factors, 5 times 2. So this is just a way to prove this. Let's just think about this in terms of x for a second. What's 0 divided by x? Well, if we convert it to our reciprocal, we can say that this is 0 times 1 over x. And what's 0 times anything? What happens when we multiply by 0? Anybody know what we get when we multiply by 0?
Zero?
It's 0. Yeah, anything multiplied by 0 is 0. So we don't even have to mess around with fraction rules here. Anything multiplied by 0 is 0. That's the rule forever. What about if I have x divided by x? Well, x divided by x, we're going to write it as the reciprocal multiplication here. So x times 1 over x. These two statements are equivalent. I'm dividing by x, which means I'm multiplying by 1 over x. What are we going to get? What's x times 1 over x again? If we were to carry out this multiplication, we've seen this one today.
One?
1, yeah, because this is like, well, we have x over 1, so it's going to be x over x, and anything divided by itself is 1. Cool. And what if we had x divided by 1? Well, x divided by 1 is going to be x times 1 over 1. Using our reciprocal rule, or multiplying by a reciprocal instead of using division. And this is like saying, well, this is like saying x times 1, because 1 over 1 is 1, which is just x. So anything divided by 1 is just itself. We probably already knew that. But you probably haven't thought about it in terms of multiplying by the reciprocal of 1. The last example is 1 divided by x. If I have 1 divided by x, that's the same thing as saying 1 times 1 over x. And anything times 1 is just itself, right? So this is 1 over x. And that makes sense. If I asked you to write 1 divided by x as a fraction, you'd probably write 1 over x. But now we're thinking about it in terms of multiplication of reciprocal instead of as division. So this is good practice, just writing out division statements as multiplying by the reciprocal. And we'll see why that's useful the more we do here, the further along we get when we're multiplying complicated fractions together, or dividing complicated fractions. I'm just looking ahead here and checking the time. Okay. So how could we compute (17) divided by 1/5? 17 divided by 1/5. How can we use the reciprocal rule that we just learned for division?
17 times 5, because
Okay, yeah. This is going to be equal to 17 times 5/1. So reciprocal is the flip, right? So we flip the 1/5 and multiply. So you've probably already done this, anybody that's divided fractions before. You have to flip the second one and you multiply. And again, when we multiply these together, this is like 17/1. So 17 times 5, we could work out and find out that that's 85. So in general, we could say that x divided by 1/y is equal to x times y. Is a general form of that. Cool. I'm just looking at some division and negation here. A lot of rules. So let's compute 12 plus 18 divided by 3. Can I write 12 divided by 3 plus 18 divided by 3? Can I use the distributive property?
I don't think so.
Brian's saying no. Yeah, and I think you'd be probably right. We can figure out what these are. 12 plus 18, that's pretty easy. We could say that's 30. And divided by 3, we could say that's equal to 10. If we do the other one, 12 divided by 3, and 18 divided by 3 is 6. So we do actually get the same thing. We do actually get the same thing. How does that happen? How does that work? The way that makes sense, we can go back and say, so this does work. This does work. This looks like a distributive property for division. Looks like we're using the distributive property for addition. I'm just going to save this slide and get rid of a bunch of my old slides here. So we could write this out a different way and say 12 plus 18 divided by 3 Well, that's equal to 12 plus 18 times 1 over 3. So now we've turned it into a multiplication. And now that we've done that, we can see that the distributive property applies, because we know that distributive property applies to all multiplication. So I can distribute this 1/3 in here and say, okay, this is 12 times 1/3 plus 18 times 1/3. And 12 times 1/3 is 12 over 3. And this is 18 over 3. And this is 4 plus 6, which is equal to 10. So by writing it as a multiplication, we can use the distributive property. We can apply the distributive property. So that's a big idea, because we've just extended that distributive property to division. Okay, what about the other way around? What about 6 divided by 2 plus 1? Is that equal to 6 divided by 2 plus 6 divided by 1?
No, not really.
It doesn't look like it. It looks different. We're going to get something different here. If we do this first bracket, we're going to get 6 divided by 3, which we know is 2. Over here, we're going to get 6 divided by 2 is 3 plus 6 divided by 1 is 6. So we're going to get 9. So we know that these are not equal to each other. So what happened? What was so different about this question? If we look, we had the bracket came first that had more than one term in it in our last example. And here the bracket comes second here. So there's something extra that's happening. Let's back up a bit and say that 6 divided by 2 plus 1. I'm going to write that as 6 times 1 over 2 plus 1. That would be the rule we just figured out. That's our the reciprocal multiplication that we figured out is, that's what division is. It's multiplying by a reciprocal. So what I'm doing, this is how it really simplifies, and it's the same thing. This is 6 times 1 over 3, if I wanted to simplify that, which is the same thing as 6 over 3, which is 2. It's just not true that it's equivalent to that. So we can't use that distributive property for division. Division is not actually commutative or associative. So that's an important point. So division is not commutative or associative. So that's the same as subtraction. Subtraction is not commutative or associative either. So what we want to do is we always want to convert subtractions to addition, because then we can use commutativity and associativity. And we always want to convert divisions to multiplications, because that allows us to use commutativity and associativity properties. Okay. So I'm just going to write something in general here. We have to be very careful. I'm going to write that what I just said in general. Convert subtractions to additions and divisions to multiplication in order to use the commutative, need another M, commutative and associative properties. So that's a good rule to remember. So what if I ask you to compute 1/2 divided by 1/2 divided by 1/2 divided by 1/2. How could we simplify this string of divisions? I don't want to have divisions. Remember, I want to be able to use commutative, associative properties. So how could I rewrite all of these division signs? How can I rewrite this without using any division signs? Anybody have an idea here? Well, if I wanted to write, remember, if I wanted to write 1/2 divided by 1/2 using multiplication, what would I write? 1/2 times what?
Two over one?
Yeah. It's equal to 1/2 times the reciprocal of 1/2, which is 2 over 1. This is the rule for division that we've laid out now. So anytime we have a division, we want to convert it to a multiplication of the reciprocal. If we divide by a number, we're multiplying by its reciprocal. So if I go back over here, 1/2 is just 1/2. But instead of this division sign, I'm going to write times 2 over 1. And then we have another division sign here. So I'm going to say, well, we're going to multiply by the reciprocal. And then another division sign, I'm going to multiply again by the reciprocal. So we can convert all of these divisions into multiplications. Is everybody with me so far? Does this make sense? Okay. Stop me if it doesn't make sense. So now that I have 1/2 times 2 over 1, that's pretty good. Anything times its reciprocal, I can use the associative property and say, multiply these two first. 1/2 times 2 over 1, that's just going to be equal to 1 times 2 times 2. And this just becomes and easy multiplication of whole numbers. Does this make sense to people? Okay. Just going to save this slide. Let's do another one. Compute 1/5 divided by 1/1/5 divided by 5. Maybe I'll just put some brackets around this, just for fun. Looks pretty complicated.
One over 5?
Okay, which part? We have 1/5. Is that the final answer? Are you saying all of this equals 1/5? Let's break this down step by step here. We need to change these to multiplications, right? We don't want these division signs in here. So what's the first division sign you want to change? What could we change here? How can I change a division sign? Well, I know that I have to convert it to multiplication, right? If we divide by something, we're going to be multiplying by the something's reciprocal. So what can I replace here? Let's change this division sign. Let's change this to a multiplication. So if I have a multiplication now, what do I write for the second? What am I writing for this second? What am I writing here? What happens when I change the division sign to multiplication? Anybody? I know it looks complicated, but we're just working with the same thing that we've been doing, right? If you have anything, x divided by y, remember that's equal to x times 1/y, right? That's the only thing we're doing here. We're converting division signs to multiplication by writing what we're dividing by as its reciprocal. So what's the reciprocal then? What is the reciprocal of this stuff? That's what we want. If I've changed this division sign to a multiplication sign, I've got to write the reciprocal of this second fraction. What is the reciprocal of this second fraction?
On the right side?
Yeah. Yeah, we just want the reciprocal of this fraction, right? We just have to flip it, right? The reciprocal is just flipping. So the reciprocal is going to be 1/5 divided by 5 over 1. That's all that happened. Just like we flipped the y here upside down. When we changed the division to multiplication, we flipped the second term. Okay. So I know that this is just equal to 1/5 times 1/5 divided by 5. Because anything over 1 is just itself. But I don't like this other division sign here. I want only multiplication signs because I'm working with fractions. And even if we're not working with fractions, it's a good exercise. It's important to do this. So this is going to be equal to 1/5 times 1/5 times what?
1/5.
Times 1/5. Exactly. Because if we change this division sign to a multiplication sign, we have to take the reciprocal. So we're multiplying by the reciprocal. Okay. Now we have a case of 3 fractions multiplying together, which is okay. Because when we're multiplying fractions, we just multiply across the top and multiply across the bottom. So we're going to get 1 times 1 times 1 on the top and 5 times 5 times 5 on the bottom, which we can work out to be 125 on the bottom. Does everybody feel okay about this example? It looks scary, but it's not. It's all just division and multiplication. So we have to convert all the division to multiplication. And this is just a regular division of fraction rule that you've probably seen before if you've divided 2 fractions. Okay. Let's try this in terms of variables, because we don't always need numbers. We can just use the letters to represent numbers. That's a big part of what algebra is all about. So we can say, I want to simplify A divided by B over C times B divided by A. Again, this looks complicated. There's a lot of there's 4 terms here being multiplied together. But we just start with one step at a time. We say, what can we simplify? Knowing what we know about division. Let's simplify, let's replace these division signs. I want to replace these division signs. So how can I
You could replace the division signs with multiplication signs by flipping the B and the C around.
Right, let's do that.
By the way, I have to leave in 4 minutes because I have to go to school.
Okay. No problem. So you're right. We're going to change these division signs. And what do we end up with? What does B over C become? And A. What do these terms become? Right? We need to take the reciprocal, right? So what is the reciprocal of B over C? What is the reciprocal of B over C?
C over B.
C over B. Yeah, it's just flipped. So I get to get C over B here. And what's the reciprocal of A?
A.
The reciprocal of A, we need to do something because A times A isn't 1. We need to get something that multiplies A to give us 1. Remember, we're just flipping it. What's the 1 over A? Yeah. There we go. So we've converted all the multiplications to divisions and changed what we were dividing by to the reciprocal of that. Now we have a bunch of multiplications which are easier to deal with because we can use the commutative and associative properties. So what is A times C over B? Let's try simplifying this stuff now. This first bracket here. This is like saying I have A over 1 times C over B. What could I write that product as?
A times C over B.
There we go. We got AC over B. And what about this second? What does the second fraction become? Or the second bracket? When we multiply B times 1 over A. Remember, there's an invisible 1 below that B.
B over A.
B over A. Okay. So I should say B times 1 over A, which is B over A. Yeah. So we could say this is equal to AC over B times B over A. Now what? Which is this multiplication simplified to? Same rules of multiplication.
AC times B over B times A.
ACB over BA. Exactly. Everything just gets multiplied together. Numerators get multiplied together, denominators get multiplied together. Cool. So, but now we have A in the top and we have A in the bottom. So this is like saying we have A, B, C all over A, B, because we can rearrange them because they're commutative. Multiplication is commutative. And what happens when we get A over A and B over B?
You can cross them out.
We can cross them out. Because this is like saying A over A times B over B times C. And A over A is just equal to 1. And B over B is just equal to 1. So we're just left with C. That's our final answer. So they obey all the same rules as numbers. We don't need to use numbers in math, which is really exciting because then we can do things in general. We don't have to talk about specific cases. We can say, we can write expressions that are true for all numbers and not just specific numbers. 1 plus 2 is always equal to 3. But A plus B equals C can be any numbers. Just gonna save my slides here. Oh yeah, I want to go back a sec. We could have, at this stage, just crossed out A's and B's. We don't need to separate them into fractions, but I just wanted to do that to show people. So when you have any sort of fraction, if you have A, B, C, D, E, F, X, Y, Z, all over, you know, A, C, F, Y, Z, we can say, well, we've got a lot of factors in the top, in the numerator that we had in the denominator. So we don't need to have all of those. We have an A over A, we have a C over C, we have an F over F, we have a Y over Y, and a Z over Z. So what this ends up being is what's left over, B, D, E, X. So get used to simplifying fractions like this. And there'll be some examples in the practice questions I'm posting right after class today. Just looking to see, we're sort of out of time here. We only have about 2 minutes left here. I don't think I have time to start the next example here. But thanks for joining me again today. I will post more practice questions from this chapter. And next week, we're going to move on to exponents. How many people have seen exponents?
I have.
Me? I have.
Cool. So some people have, some people haven't. That's okay. Exponents are fun. They allow us to write multiplication in a more compact way. And there's a whole bunch of rules that we're going to learn that is going to make math way easier than writing multiplying out all the time. Exponents are some of my most fun things in math, actually, the rules, because they make things so much easier. So I'm looking forward to doing that next week. Thanks for joining me again, everybody.